Hey everybody, in this video we'll try a practice SAT math style question. So we're going to suppose 3x minus y is equal to 10, and we are asked to find what is the value of 8 to the power x divided by 2 to the power of y. And we have 4 possible answers to choose from as usual on the SAT. And the fourth answer is that perhaps this value cannot be determined from the information given. So that's interesting. Well, as usual, you'll want to pause the video at this point, give this question some thought, and when you're ready, unpause it and we'll talk it through together. All right, so let me give you a couple of hints in case, as you were thinking it through, you were not quite sure how to start. So I'll say that when I first saw this problem, maybe what occurred to me that gave me a little bit of insight as to which tools in my math toolbox I might want to have ready for this particular problem. So I noticed that we have a lot of powers of 2 going on here. We have 2 to the power of something, 4, well, that's 2 to the power of 2, isn't it? 2 squared is 4. We have 8, 2 cubed is equal to 8, or 2 to the power of 3, in other words, is equal to 8. So all of these things have something to do with powers of 2. All right. And so maybe that means I want to think in my mind here. I wouldn't necessarily take time to write this all on the SAT if I were doing it, but maybe I would want to think to myself that 8 to the power of 2 can be thought of as 2 cubed to the power of 2, right? And similarly, 4 to the power of 4, I could think of as 2 squared raised to the power of 4. And let's see, maybe then I also want to remember something about, what is that property of exponents again, where if we have a base like 2 in this case, raised to a power, and then all of that stuff is raised to a power. How does that work again? Well, so maybe what we want to recall, as a little bit of an extra hint here, is if we have a setup like, let's say, a to the power of m, and then all of that is raised to the power of n. Well, in that instance, what you have is a to the power of m times n. Okay, and maybe one other hint before we talk it all through is if we look at this expression here, like our goal expression that we're trying to find the value of, we have division. We have something to a power divided by something else to a power. And there's a property of exponents that has something to do with that. So let me remind you about what that is. So let's suppose we had a to the power of m divided by that same a, whatever number a is, to the power of n. So what do we do to simplify an expression like that? Well, in this instance, we would subtract the exponents. So that would be a to the power of m minus n. Okay, so that's perhaps a couple of small hints that you may find useful to give this problem a try, if you have not already. So once again, I will invite you to pause the video at this point, ponder a little bit, see if you can work out a proposed answer, and then we'll talk it through. Okay, so hopefully by now you're ready to talk through the solution with me. So I'll show you how I would work this problem out. And based on the fact that it's a multiple choice question, I can actually think of 2 approaches here. The first approach that I'll show uses kind of these properties directly, and I felt like that was probably the most efficient approach. But since the SAT is a multiple choice question, maybe I'll point out another approach as well, that if you, maybe if you didn't think of these properties right away, maybe if something else came to mind first and you just wanted to test the plausibility of the given possibilities, then you might be able to work it out that way as well. So I'll talk through 2 different methods. So method 1, let me start with my given expression here, 8 to the x divided by 2 to the y. And since I noticed earlier that all of these numbers involved here are powers of 2 pretty much, right? So I would like to get both the numerator and the denominator written with 2 as the base. So I'm going to substitute 2 to the power of 3 in place of 8 here. So now I have 2 to the power of 3 to the x, all divided by 2 to the power of y. And then, according to my property over here, that means 2 to the power of 3 to the power of x. Well, that's equal to 2 to the power of 3 times x. And that's all divided by 2 to the power of y. Okay. Well, what do I do now? Well, now I can see a couple of options. One thing I guess I could do is I could realize that by my second property, I have something that resembles exactly this setup right here. I have something raised to the 3x divided by that same something, 2 in this case, raised to the power of y. So why don't I substitute in place of that 2 to the power of 3x minus y. So what do we have now? Well, what do we know about 3x minus y? Well, conveniently, we were given what 3x minus y is, right? We were given that it's equal to 10. So this right here is equal to 2 to the power of 10. Why? Because we were told 3x minus y is equal to 10. So if we substitute, then we get 2 to the power of 10. And we see that the correct answer is C. All right. Not bad, huh? All right, so that was method 1. Well, how about method 2? So let's suppose maybe when we first noticed this question on the test, what if these exponent properties didn't come to mind right away? What could we have done instead that might also have helped us to come up with a solution to this problem? Well, I would then say it may be useful to make up some possible values for these numbers x and y, which do satisfy the given condition that 3x minus y should be the number 10. Why do I think that might be a helpful idea? To help us get some experimental evidence, let's say, about which of these possible answers is the correct one? Well, if this expression here, 8 to the x over 2 to the y, is indeed equal to either a or b or c, no matter what x and y are, see, these are just constants, right? They don't depend on x and y. So if either A or B or C is correct, then they must be correct. Whatever answer it is must be correct for any pair of x and y that satisfy this condition. So maybe thinking along those lines, what we could do is choose arbitrarily a pair of numbers for x and y that make this statement true. So let's try that. So let's try choosing an x-y pair, a pair of numbers x and y, so that the given condition up here, so that this condition is true, so that 3x minus y is indeed equal to 10. Okay, or in other words, so that is, maybe a more convenient way to write that would be if I rearrange this a little bit to move the y to the other side, move the 10 to the other side, then we would get y equals, let's see, 3x minus 10, right? Okay, so maybe what I could choose is, so maybe pick x equals, I don't know, what looks like a good value to pick for x to plug in to right here so that I get some nice convenient values. Maybe 3 or maybe 4. Let's try 4. Let's try x equals 4. So if I pick x equals 4, then my y value must be, let's see, 3 times 4 minus 10. That should be 12 minus 10. That's 2. Okay, so in this case, when x is 4 and y is 2, our object of interest here, 8 to the x over 2 to the y, becomes what? Well, I guess it becomes 8 to the power of 4 over 2 to the power of 2. And, well, now what do I do? Well, I suppose if I were really stuck, I could take my calculator out and ask my calculator to compute 8 to the power of 4 over 2 to the power of 2. And I could compare that result to what I get with A and B and C. Or maybe this line of reasoning is now what leads me to recall that, oh yeah, well, if I have 8 and 2, and those are both powers of 2, maybe this is the experiment that reminds me of these handy exponent properties, right? So there's a couple approaches there that might have worked. If you did at this point recall your exponent properties, then maybe now would be the time to notice, okay, so 8 is indeed equal to 2 to the power of 3. And then what we have is 2 to the power of, let's see, 3 times 4, so that's 2 to the 12, divided by 2 to the power of 2. And what do we get then? Well, we get 2 to the power of 12 minus 2, and that's equal to 2 to the 10. All right. Well, that looks an awful lot like answer C, doesn't it? And that wasn't a coincidence. That wasn't just what would have happened if I chose x equals 4 and y equals 2, if I had picked a different pair of x and y as my test case numbers, if you will, and provided my test case numbers satisfy the given purple condition, then in any case, I would have ended up with something equivalent to 2 to the power of 10 once again. All right, so we've seen 2 methods to attack this particular style of problem. I hope you found this video helpful, and I'll see you in the next one. Bye for now.